Okay, last video we finished off with me telling you to go watch video 2 in lesson plans for April 13th, Monday. Hopefully you watched that, and if you needed to take any notes on that. Now we're going to continue in with the lecture from my class, and this one talks about calculating the mass of 0.5000 moles of helium atoms. And it says it's a one-step problem. So it's saying calculate the mass. So we've got mass here. And it says of 0.5000 moles of helium atoms. Okay, so we have a given of moles, and we're trying to calculate the mass. So we're going between mass and mole. So let's go ahead and do this problem. Okay, so our given is 0.5000 moles of helium. Okay, so this is our given. So this is going to be our upper left. Okay. We are going from moles of helium to finding the mass, moles to mass. So if I have moles here, this is what I'm trying to find. And so I would put grams for mass, grams of helium. Okay, now where do I get this number? Grams for helium. Anytime you see the word mass or grams, we need your periodic chart. So we would go over here and go to helium. Helium's up here in the right corner. And you can see the mass for helium is 4.003 grams. So we're going to go ahead and go back and put that on the screen. And I just remembered it would delete it, yeah, but it doesn't save it anyway, so I guess it's a glitch for the system. Okay, so we've got our Okay, so we've got our 0.5000 moles of helium. I wish I could switch screens and not lose all my writing, but I'm not sure. It says it saves it, but it doesn't. Okay, so 0.5000 moles of helium, and we said our to find is mass, so we would have grams of helium. Okay, and we just looked that up and said that is 4.003, so 4.003 grams of helium. Okay, what goes on the bottom? Remember, they have to match units. Okay, so our units have to match. So we're going to go ahead and put moles of helium on the bottom. Moles of helium. Okay, and we're looking at this ratio. How many moles equals 4.003 grams of helium? Remember, we said 1 mole of any element is the same as its molar mass, right? It's mass from the periodic table. So it's just 1 still. Okay, so we are multiplying the top. So you're going to take 0.5000 times the 4.003, and we get a total of 2.0015. And of course, we can't leave it with all those numbers. Beginning, we had 0.5000 okay, which are 1, 2, 3, 4 digits, right? And so we can only have 4 digits here, so we're going to round it to 2.001. And these are our units that were left over, which is grams of helium. Okay, so this is for going from moles to mass. Okay, let's go ahead and go to the next screen. What is the mass of 5 moles of krypton atoms? And so this one, we've got 5 moles going to mass. Okay, so this is the same type of problem as the last one. The only difference is now we're looking at krypton. Okay, and we're still going from moles to mass. So it's still that one step. Okay, so go ahead and try to calculate that on your paper. And then the next question we have is how many copper atoms are in a 4-gram sample of pure copper? So notice this one is actually giving us 4 grams, the mass, and asking us to find the atoms. So this is a 2-step, okay? So I want you to try to work those out on your paper. So go ahead, pause this video and see if you can figure them out. Okay, hopefully you've figured these out on your notes. Let me go ahead and show you this one. So this is moles to mass. So we've got 5.00 moles of krypton, which is actually Kr. Oh, no, potassium. I'm sorry. Never mind. I'm having a brain lapse. Okay, potassium. K. So we've got 5 moles of potassium, and we're trying to find out, well, what are the grams or mass of potassium if we've got 5 moles? Okay. So where do we go to look up potassium? Remember, we've got to go and we've got to stay. I tried to save it. Let's see if it works. Probably won't. Okay, so potassium is over here. Here's potassium, 39.10. 39.10 is the mass. Okay, so we're going to go back to the screen, and I can already see it did not save it. Yay! Zoom, this is a glitch you need to fix because it is annoying. Okay, let me go ahead and put that back in. So 5.00 moles of potassium, and our find is we're trying to find mass. Okay, so we've got given moles of potassium. Now we have grams of potassium, and we said potassium had 39.10 grams. 39.10 grams from the periodic table. Remember, we want to match our units, so we can get rid of them. Okay, and so on the bottom, we're going to put 1 mole of potassium. 1 mole of potassium, because remember, 1 mole of potassium would equal its grams on the periodic chart. Now, how do we finish this off? We're going to go ahead and multiply the top. And so go ahead and calculate that. 5.00 times 39.10 equals, and the answer is 195.5. Okay, starting out, we only started with 3 sig digs, so we need to round to 3 sig digs. So we're going to put 196, and we're going to use our units. You must have units at the end and use units in this process. Okay, some of you are going to skip out on units when I grade your quizzes and tests. If you don't put units in there, you lose credit. Okay. And also, some of you are going to ask, do I have to do it this way? Yes, you have to do it this way. You must learn it this way. So I need to see you having your given, your find, and then your mole ratio. Okay. Okay. Let's see what the next one is. This one was a 2-step. Okay. And so the question was, were you able to do this? So you could do 2 little mini problems. So first we would have to go, if we're going from grams, 4 grams to copper atoms, remember we can't just jump, right? Okay, you remember we can't just jump from, we would have grams, right? We have to go to moles first. And then we would go down to Avogadro's number, 6.022 times the 10 to the 23rd. Okay, so if we're doing atoms, we need Avogadro's number. Grams, we need the periodic table. So anytime you see grams, you need the periodic table. And atoms, formula units, molecules, any of that, you need Avogadro's number. Okay, so let's go ahead and look at this problem. First, we would convert it. We would first go from grams, right? Grams to mole. So the first step is 4.00 grams, and we're talking about copper, so Cu, copper. Okay, that's our given. We're going to find first moles. Okay, so moles is going to go on top in the middle, or on top the next step, moles of copper. Okay, and if I wanted to do all 3 together, I could. What I like to put them all together because it just saves you time from having to make too many problems. So if I'm going from grams to mole and then to Avogadro's number, all I got to do is just make 3 areas. Okay, and so now this would be atoms of copper. Oh, that's just terrible. I don't know if I'm going to get any better with this mouse writing. Okay, so notice they're all the stepping stones are on top. Grams, grams, mole, mole, atoms, atoms. Okay, well, without thinking about numbers yet, what goes on the bottom? Well, remember, diagonally, they have to match in order for us to cancel out our units and end with what we want, which is atoms of copper. Okay, so on the bottom, we're going to put, I've got grams of copper here. I'm going to put grams of copper here, grams of copper here. I've got copper moles here. Then I'm going to put copper moles here. Okay, now I've got all my units in. Okay, your stepping stone, grams to moles to atoms, grams to moles to atoms. And then we matched our units, grams to copper, so that we can cancel out. Now let's look at the numbers. How many copper moles will equal how many grams of copper? Anytime we have mole right now, if we're comparing copper with copper itself, it's a 1 mole. If we need copper, grams, or mass, we've got to look at the periodic chart. And I'm not going to go to it, but you can look it up. And it has, for copper, 63.55. 63.55 grams of copper. And then now we have another ratio. How many atoms of copper will go with a mole of copper? Well, copper, 1 mole. And what is the atoms number? Avogadro's, 6.022 times 10 to the 23rd. Okay. And all we're doing now is we have numbers on top and we have numbers on the bottom. Okay. You could multiply everything on top and get a top number, and then multiply what's on the bottom and then divide it and come up with an answer. Okay. I personally, I just do this. Okay. I will take 4.00 grams and I will divide it by 63.55 and push equals. Once I push equals, then I say times 6.022 times 10 to the 23rd for Avogadro's number. And then I push equals, okay? What I do is everything, if you push equals between each calculation, you don't have to put it in parentheses. Just 4 grams divided by 63.55 equals times 6.022 times 10 to the 23rd equals. Okay, every time you're on the top, you're multiplying, and if you're doing it my way, you're just dividing. So I could endlessly multiply on the top. This times this equals, times this equals, divided by this equals, divided by this equals, and come up with the answer. Okay, I don't put parentheses in. I don't have a calculator that even puts parentheses. So it's a lot easier for me, rather than to put all these fractions in, just to go this divided by this equals times this equals. Okay, we're coming up with 3.79, huge number, times 10 to the 22. We have 3 numbers here, so we need to round to 3.79 times 10 to the 22nd. And these are our units at the end: copper atoms, copper atoms. Remember, a calculation is nothing if you do not have units, okay? So this one is 3.79 times 10 to the 22nd copper atoms. And we'll go ahead and clear this. And there is one more problem, I believe. Okay, how many atoms are in 3.33 times 10 to the negative 2 grams of gold? Okay, so this is starting with grams of gold and going to atoms again. Okay? So you're actually going to set this up exactly like this. Nothing has changed, okay? You're going to have the exact same steps here. Pretty much everything's going to be the same, except your grams for gold is going to differ than grams of copper, right? But your given is not 4 grams, it's actually 3.33 times 10 to the negative 2 grams, okay? And so go ahead and do that, work that on your own, and I think you should be good and get that answer. Okay, 9.3, compounds in the mole. Masses of compounds can be found by adding up the atomic masses of each atom they contain. So if we're trying to find masses of compounds, we're just adding up the individual masses of each element. So if we wanted the mass of water, H2O, there's 2 hydrogen, 1 oxygen. From the periodic table, 1 hydrogen has 1.008 grams. So if I multiply by 2, and then there's only 1 oxygen, 16 grams times 1, and it gives me a total of 18.02 grams. Okay, water contains 2 moles of hydrogen and 1 mole of oxygen. Okay, give the masses of the following. So NaCl, we look up, there's 1 sodium, 1 chlorine. So from the periodic chart, 22.99, 35.45. You add those together, 58.44 grams. We could also say grams per mole if it asks you for molar mass. Okay, what about CO2? 1 carbon is 12.01. There are 2 oxygens, so we have 16 plus 16, 44.01 grams of carbon dioxide. And what about C6H12O6? Big numbers. Carbon times 6, which is 72.06. Hydrogen, 1.008 times 12, which is the 12.10. And then oxygen, 16 grams times 6 is that 96. So all of these come from the periodic table. We multiply them by 6, 12, and 6, and then we get a whole total of 180.2 grams. Okay, problem calculating molar mass. So find the molar mass of aluminum sulfate. How many atoms of do we have of each? Okay, so we've got aluminum. We've got 2 atoms of aluminum. 3. Remember, this is distributed. So 3 times the 1 sulfur is 3 sulfur. And we have 12 oxygen. So we're just going to get the masses of aluminum, sulfur, and oxygen, multiply aluminum by 2, sulfur's mass by 3, oxygen by 12, and then we have a total. The answer should be 342.2 grams of aluminum sulfate. Okay, we're going to go ahead and stop right here because I think it's roughly enough time for you to work on problems and to do some other classes, okay? You guys, until next time, take care.